And we continue our topic of linear functions, and now we're going to discuss how to write an equation of a linear function. So here in this example it says write an equation for a linear function given a graph of f of x shown. So we have basically two different formulas that we could use. So one formula is f of x equals mx plus b. And in order to use this, we need to know m and we need to know b. And the question is, can we read those values from the graph? And I hope you're saying yes. So in order to figure out m, we need two random points on this line. We can select any 2 points to figure out m, and b is your y-intercept. So I hope you see right away that b equals +2. Now let's find m, and like I said, for m you can select any 2 points. So I would choose the points that are clearly like on the intersection of these unit marks, you know, that I don't have to guess which what are the coordinates. So for example, this would be one of my points with coordinates 2 and 8. And the second, I would choose, well, y-intercept, why not? That is 0.02. Okay, so I'm gonna use points 0, 2, and 2 and 8 to find m. Okay, so let's label them. 0 is x1, 2 is y1. 2 is x2, and 8 is y2. So putting that into the formula, we have 8 minus 2 over 2 minus 0. So we have 6 over 2, and that's 3. So basically I have everything that I need to write an equation. I have b and I have m. Okay, so I can go back and plug those values in. So my f of x is 3x plus 2. And that's the equation of that line. Okay, so that's a little refresher on how to find an equation of the line. Let's go ahead and look at the next example. Now this video is going to be example heavy. And here we go. We have, suppose Ben starts a company in which he incurs a fixed cost of $1,250 per month for the overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function c where c of x is the cost for x items. Okay, so first of all, I want to point out that they were very nice to us, and they told us that it's a linear cost function, which means that we can use our linear model, which is f of x is mx plus b, and all we have to figure out is our initial cost and then the rate of change of the cost. So let's think about it. So the cost, does the cost depend, what does it depend on? Well, it depends on the fixed costs that you have to pay, like for example, salaries to your employees, insurance, and rent. So that will be your overhead cost, and it does not change, right? It's basically the same each month. Um, and they told us that it's 1,250 per month. So this would be your initial value. So before you even started producing anything, this is what your cost is. So this is cost of 0 units produced. That's initial value is $1,250. Okay, so that's your initial value. In other words, this 0 right here means what even before you produce any items, you already spent this much money. Okay, and then we have a rate. So there is a cost for producing one item. So that's your rate right here. So rate, or M, and by the way, your initial value is B. So M is 37.50. This is the rate per one item produced, right? So the total cost is going to be your M, which is 37.50, times your X, how many items you're producing, multiplying that cost per item times the number of items, right? Plus your overhead cost, 1,250. So this is it. This is how you write your function. So again, three things. First of all, we know it's a linear function. So we know we need the rate and we need the initial cost. Once you identify those, here you go. That's your function. Let's consider another example. And here, this example is slightly different. It says, if f is a linear function with f of 3 equals -2 and f of 8 equals 1, find an equation for the function in slope-intercept form. So here they told us that this is a linear function. And what are those? Well, those are our ordered pairs. Those are our points. So this is your x value and this is your y value. So we have a first point, 3 and -2. And then we also have x and matching y value. So this x1, y1, y1. This is x2, y2. So this point is 8 and 1. Okay, so we have 2 points, and like we discussed before, we haven't discussed this type of problem yet, because in the one that we just looked at the beginning of the video, we had a y-intercept. And for this one, we don't have a y-intercept. So question, what do you do when you don't have a y-intercept? Well, we have another equation of the line. It's called a point slope form. So the point slope form, let me write it here. This is point slope form of linear equation. And the point slope form is y minus y1 equals m times x minus x1. Okay, so y and x here are general. Basically, they're general x and y, not non-specific. But these ones, x sub 1 and y sub 1, those are coordinates of a point that's on the line. So these values come from the point. on the line. Okay, why do we need 2 points? Because we need 2 points to find m. Okay, otherwise, but once we found m, from that point on, we will only need 1 point to complete this equation. And for the curious ones, this equation comes from our slope formula, which says m equals y1 1, 2 minus y1 over x2 minus x1. If you multiply both sides by the denominator, you will come up with this equation. All right, so let's do this. We're gonna find m first. So we have 1 minus a negative 2, a double negative again, and then 8 minus a 3. So that gives us, again, 3 over 5. 3/5 is our m value. Okay, and then we pick any one of these 2 points to plug it into this equation. Okay, so whichever point looks, I don't know, better to you. So it's your choice. I'm gonna pick the second one. I like positive values. I like the 1. Easy numbers, not that those are difficult, but and I'm gonna plug those values in. So I'm gonna copy this equation here. Y minus y sub 1 equals m times x minus x sub 1. Okay, so what am I plugging in? I'm plugging in 3/5 for my m value, and I am plugging in the x for my coordinate of a point, and I'm gonna plug in 1 for the y coordinate of that same point. Okay, and these could be any. This could be xy, x1, y1, could be x2, y2, could be x3, y3, as long as they're matching coordinates from the same point. They could be anything. Okay, so let's finish this. So we have y minus positive 1 equals 3/5 times x minus 8. All right, so what are we going to do now? Basically, this is it. This is the equation. But in order to bring it into nice slope-intercept form, we need to solve it for y. So what we're going to do, we're going to distribute the 3/5 first, and then we're going to bring this 1 over to the other side. And you know what? I'm going to actually bring it here. So y minus 1 equals, I'm distributing 3/5. So I have 3/5 times x, and then minus, so the 3/5 times negative 8 is going to give me a negative number. So 3/5 fifths times the 8, 8 over 1. Cleaning it up. 3/5 x minus 3 times 8, 24. 5 times 1 is 5. Okay, now I'm going to subtract, or rather add 1 to both sides. And all right, so this goes away, and we have y equals 3/5 x. And now the 24/5. Now I'm going to rewrite this 1 as a fraction, and it's going to be 5 over 5. I need the same denominator in order to combine the numerators. So keep on solving. Negative 24 and a positive 5 give me negative 19. It's going to be negative 19 fifths. And this is it. I will leave this equation in this form. Like I don't have to, it's an improper fraction, but we don't have to actually, you know, put it into a mixed number. Not now. I mean, when you're working on applied problems, then maybe if that sometimes it makes more sense, or if you're graphing, it's easier to graph mixed numbers than improper fractions. But unless you're told to, you know, use mixed numbers, then don't do it. That's as far as I'm concerned. Okay, so here's a problem that I'd like you to try, and it reads, if f of x is a linear function with f of 2 that equals negative 11 and f of 4 that equals negative 25, write an equation for the function in slope-intercept form. Okay, so go ahead and give it a try. And we're moving on to the next example, using linear functions to determine the number of songs in music collection. Marcus currently has 200 songs in his music collection. Every month he adds 15 new songs. Write a formula for the number of songs in his collection as a function of time, the number of months. How many songs will he own at the end of 1 year? So here they can you identify the input and the output for this linear function? I want you to pause here and to think about it for a second. So hopefully you observed that the input is time in months. How do we know? Well, they told us here, function of time. And what is a function of time? The number of songs. So the output is the number of songs in each, right? So if it wasn't given, another way to think about it is which variable depends on which. Does the number of song depends on the time, or does the time depend on the number of songs? So what would you what would you want to know first before you answer the question? And hopefully you said time, because that what gives you the direction on, or the idea of the number of songs that this Marcus is going to have. Okay, so as we identified it, so we're going to have n of t. Now, in order to write the formula for figuring out n of t, first of all, we know that it's a linear function, right? So we need the rate of change, and we need the initial value. So we're going to start with the initial value. So the initial value, B, is the number of songs that he currently has in his collection, so 200. And then what's the rate of change? How is his collection changes? So, and that's M. Well, they said that every month he adds 15 songs, and our increment of time is in months. So 15 songs per month, that's the rate of change. Okay. So once we know that, we're actually ready to write out our equation. Remember, it's the rate of change times your variable x plus the initial value b. And that's your equation. All right. Moving on to the next example. Using a linear function to calculate salary based on commission. Working as an insurance salesperson, Ilya earns a base salary plus a commission on each new policy. Therefore, Ilya's weekly income, I, depends on the number of new policies in. So here's an example of when they give you the independent and the dependent variables straight out, your input and your output. So here, this phrase tells you that your input value is n and your output value is I. N is your independent variable and I is your dependent variable because it depends on n, right? So your function is going to be I, the function I of n. All right, let's read on. He sells during the week. Last week, he sold 3 new policies and earned $760 for the week. The week before, he sold 5 new policies and earned $920. Find an equation for I of n and interpret the meaning of the components in the equation. Okay. So this one is a little bit different from the previous problem in how they don't give us the rate of change. They don't give us the initial value. What they give us is the I and n values for different instances. So your input or your n values versus your output or I values. Let's figure them out. So it says an N is the number of new policies, right? So it says last week he sold 3 new policies, so N was 3, and earned $760. So 760. When N was 3, his earnings was 760, right? And then, so that's one instance. That's your X1, Y1. And then after that, they told us that he sold 5 new policies the week before and earned $920. So this is going to be your X2 and Y2 values. So we have 2 points. Basically, whenever they give you 2 snapshots in a certain period of time, that's when you know you're going to be dealing with this type of problem where they give you basically two ordered pairs, X and Y. Remember that problem that we did with the population growth? Same thing. They gave us 2 snapshots in time. Okay, so we have 2 pairs of X and Y values. We have 3, 760 and 5, 920. That's what we're gonna use to figure out our equation. So what did we say we need to figure out first? And if you said slope, m, or the rate of change, you were right. So the rate of change, 920 minus 760 over 5 minus 3, which equals to 160 over 2. Now, what are the units? Well, what is 160? 160 is dollars, right? And on the bottom, the X values, they're new policies. New policies. So here, uh, we have actually the rate that he's paid for new policy. If we actually go ahead and divide it out, we're going to have he's getting paid $80 per policy. So this is our rate of change. What about the initial value? Well, we don't see it anywhere, right? We would have to figure it out. Since we don't have the initial value, that means we don't have the y-intercept. So we're going to use our equation y minus y sub 1, our point slope form, okay? And for this, we're going to choose any one of those two points. I'm going to go with the first one, with this one. So I'm going to stick x into x1 and the y into y1 into this equation. So I have y minus 760 equals m. I just found it to be 80 x minus 3. Okay, so y minus 760 equals 80 x minus 240. And then I'm going to add 760 to both sides. And that gives me y equals 80x plus 520. Okay, so this is my linear equation. We already said, well, I just want to mention that we need to use the units that they told us. They told us that the input is actually N and the output is actually I. Okay, so I of N is 80 times N plus 520. So that's what you would actually, that's what your final answer would be. Okay, this is your final um, function that they asked you to find. But let's talk about different, they also told us to interpret the meaning of the components. So we already mentioned that 80 is the rate per policy, right? What is 520? 520 is the initial value. That's the salary that he is paid no matter what. Okay, so if he makes 0 policies, this is what he will get anyway. So this is initial payment. Initial payment, which or salary, which does not depend on the policies that he sets. That's the money he gets no matter what. All right, guys. So now I have the last example that I want to cover in this video, and it's using tables to write equation of a linear function. So here it says table 1 relates the number of rats in a population to time in weeks. Use the table to write a linear equation. Well, first of all, they already told us that it's a linear equation, but if you're not sure if it is or not, we need to check that. And so that means we're gonna have equal increments in x values, right? So this is plus 2, plus 2. So from 0 to 2 is 2. From 2 to 4 is 2. From 2 to 6 is also 2. And we want to see a nice pattern with your y values as well. So from 1000 to 1080, that's plus 80. Okay, and then to the next value, it's also going to be plus 80. and plus 80. So yes, it is a linear pattern. We're good. And so again, we need to find the slope, and we don't have, oh, yes, we do. Do we have a y-intercept here? Yes, we do. Okay, so remember that for y-intercept happens when x equals 0. And do we have a point where x equals 0? And I hope that you said yes, we have it here. So the y-intercept for this linear model will be 0, 1000, right? So when x equals 0, y is actually 1000. So that's your y-intercept. What is your rate of change? Actually, when we did this, we already figured out the rate of change. So it's the change in y. Remember, your rate of change is change in y over change in x. So how much your y changes? Well, it changes 80 units, right? And it's actually the population of reds. Over, what's the change in x? 2 weeks, right? So that's it. That's 40 per 1 week. 40 reds per week is added. They're multiplying. Okay, so we have our m, we have our y-intercept. We already, so this is y value is actually your b for the model. So we have f of x equals, it equals m, which is 40, your rate of change, times x plus the initial value, 1000. So they started interpretation. They started with 1,000 reds, and then they're multiplying. So 40 new reds are born every week. Okay, guys, but I didn't pay attention. They gave us the labeling that we need to use. Instead of f of x, they want to use p, the population that depends on w weeks, right? And x is actually, the input value is weeks. That makes sense. Okay, so actually, when they give you the notation and the labels that they want to use, it's important to use them. Okay, guys, so that was the last video for, the last example for this video, and I want you to try this problem by yourself. It reads, a new plant of food was introduced to a young tree to test its effects on the height of the tree. Table 2 shows the height of the tree in feet, X months since the measurements begin. Write a linear equation h of x, where x is the number of months since the start of the experiment. Okay, guys, so I want you to try this and let me know how it goes. And I'll see you in the next video.